Okay, so this is going to be on lenses and mirrors. Checking my focus here. You have to take basically the autofocus off when you do this or else it would keep messing up. For this, you're gonna need a ruler to draw the pictures, and I'm using a plate. This is a Corelware plate. I think it's made in New York. In class, we would be using obviously rulers and then protractors. But anything that's a circle should work. So let's just go through some of the initial notes here. If this is during our amazing online sessions, I'll give you these notes right here, okay? Not going to be in PowerPoint form. They're just going to be in how I kind of make my notes out for the class sometimes, right from the book. Chapter 25, we're still on that one from the OpenStax book. And one of the things you're going to notice here is that, you know, just like with other things, like I use an I for initial instead of like a little O. I always use I for initial. Whatever it says in the book as far as how they label things may be a little bit different, maybe even from my notes because I sort of went with the book, but just kind of freehanding the notes here, I might use different things like DI for image distance instead of, what do we got here, Q and whatnot, or DO for object distance where they might use a P. Now, why do we use those weird letters? Beats me, okay? But anyway, this is entitled, it's titled Mirrors and Lenses or Lenses and Mirrors. I probably should have put the mirrors first. So basically, everybody should know what a mirror or a lens is. Now, we're going to be focusing on a few different types. As far as our mirrors go, we're going to focus on a simple flat mirror. We're going to focus on a concave mirror, and our light's going to be going this way. And we're going to be focused on a convex mirror. Okay? So, in the flat mirror, our light rays simply, if they were all coming parallel, hit and they bounce straight back. I mean, it's the mirror that we look at all the time in a bathroom or whatnot. A concave mirror is known as a converging mirror because all of these rays, if they're all parallel to each other, go... Well, that made me jump. Something just went past outside like a trailer. But they all focus on a focal point, this point F. So it's called a converging because they all come together. A convex mirror is known as a diverging because they hit. This one would bounce straight back. This one would bounce this way. But you see that the light rays do not come together. Okay? They diverge. So you may ask yourself, how do we even see anything? And we'll get to this when we do the drawing. So basically, if you were to dot these lines back, they form back behind the mirror. If you have a spoon, you could look at the concave part and see what you look like. You'll probably be upside down. And if you look at the convex side, you'll probably be right side up, but yet like look really far away. Okay. And so here's, I used some of these mirrors and whatnot when I was doing some demonstrations with light. And we have our lenses here too. So this, for example, if light was coming in this way, these are converging. If light was coming in this way, they'd be diverging because there's a mirror on each side. Okay? And if you take a look at these, if you made a big circle out of this one, okay, I think we could tell that it's going to be a bigger circle. This one would be a smaller circle. And so if we think about it here, where would the focal length be, the focal points, let's say for now, for each of these? Where would the place be that the light would come together? This one, hopefully you'd be able to kind of figure out in your head that they would come together somewhere close. This one would be further away. Okay, and we're going to get into all of that. All right, so those are three types of mirrors that we're going to be dealing with. Now our lenses, seems like my markers, like it depends where I write if it's running out of ink or not there. Our lenses, we're going to use two. Now we focus on thin lenses. I draw them as fairly thick, and even my little demonstration ones here. Oh, here's my flat mirror. I did not know where my converging one went. Here it is. But if you take a look at those, I mean, those are pretty thick, okay? And in class, we focus on if they were like not like this, but like really, really thin. And the reason for that has to do with refraction. So if we had a really thick lens, we would have to put particular importance on like the refraction at this edge and also the back edge. If it's super thin, okay, or just, I don't want to say super thin, but just pretty thin, basically what we act like is there's only one place where it refracts, and that's going to be right in the center of the lens, okay? So you could write down that these are thin lenses, whatever thin means to you for this period of time, okay? And so the different thing here, see how this is a convex mirror? This right here is a biconvex lens, okay? Why is it bi? There's two sides that are convex, okay? And this is actually our converging one. So it's like the opposite, you would think, right? This is the diverging. It has the same sort of shape. This is the converging. So there's going to be some point over here where the light rays actually come together and form a point. If you've ever like taken a lens out and tried to, I did this in class actually one time, different school, but we took big converging lenses out and we were able to actually get like dandelions to smoke and actually catch fire, which was pretty slick. This right here is known as a diverging lens, and it is a biconcave. Sometimes students have a hard time diverging. They have a hard time remembering, like, is it concave or convex? Think it's a cave, right? When you go into a cave, there's like this opening. That's kind of, if I had to, how I would remember. Okay. Now we do have some other lenses that we could use. Okay. Something like this, if the light rays were coming this way, we call it a plano, meaning plane like a flat side. Plano, convex, and if we had something like this, we'd call it a plano concave. All right? So that's just the basics, okay? The very, very simple basics of lenses and mirrors. I'm going to put a little extra note here. When we start drawing them, this will be a little more apparent, but I'm going to talk about two things right here called center of curvature, if I don't run out of room, and then focal point. Sometimes you'll hear me call it the focal length, all kind of different things, and I'm not sure what the book will call center of curvature, okay? But if we had a big plate, okay, and we're going to do this, and we draw a circle around the whole plate, or if we didn't even do that, let's just say we cut the plate in half, or you had like a protractor, and you draw a half a circle, the center would be the center of curvature, okay? I think that makes sense, the center of the curve. Now, the focal point, or the focal length, will always be 1/2 of C, okay? So center of curvature we'll call C. So if here's our mirror, the center of curvature is going to be here. And so F, the focal point, is equal to 1/2, I don't know why I did that, that's kind of weird, 1/2 of C. So basically it's just halfway. So if your center of curvature is at 2 centimeters, let's just say your focal length or your focal point will be 1 centimeter. And we're going to use that idea when we start drawing our pictures. All right? Long-winded for not that much information. We'll get into the drawings next, the ray diagrams.